Hiya. So I'm gonna do the notes that we left off on. So on this page, on the back, we have the product rule and our quotient rule. So we're gonna be on this page solving these problems. The reason why there's work here now is because I thought I was recording and I actually wasn't. Oops, my bad. So I'll walk you through what I've done so far. The directions say that we need to find the equation of the tangent line to the graph of f at the indicated point and then use your calculator to confirm. So basically we need to find the slope m at the given x value. And that given x value is given here as this point. So we need to find the slope m at the given x value. So in order to find slope, we need to find the derivative. So the first thing I did here is I applied the product rule. So I took this first term and I multiplied it by the derivative of the second term, and then I added and took the second term and multiplied it by the derivative of the first term. Okay, so I applied the product rule there, and then I distributed in this step, distributed everything out, and then combined like terms. Okay, so all I've done so far is found the derivative, and now I'm going to find the slope at the point where x equals 1. So I have the derivative, and I'm going to find it at the point x equals 1. So here I'll have 12 times 1 squared minus 34 times 1 plus 12. And this is going to equal to, I'll have 24 minus 34 equals negative 10. So basically, m equals negative 10. So I can make an equation using this point, and it's going to be y plus 3 equals negative 10 x minus 1. And here's my equation now. Cool. I'm just going to do that one example here. So when we need to find the tangent line at a given point, find the derivative, and plug in the x value to find the slope, and then use the point to write an equation. So this one wants us to determine the points at which the graph of the following function has a horizontal tangent. So where it has a horizontal tangent, remember the tangent line is the slope, and to be horizontal it's going to look like this. So it's where the slope is equal to 0. So here, the horizontal tangent means find where f prime of x equals 0. So where the derivative is 0 is where the slope is going to be 0. Let's do it for this one here. Okay. So in C, we have a quotient. So in order to find the quotient, I'm going to apply the quotient rule. So this is where I get to sing my song, low D high minus high D low over the square of what's below. I guess it's more like a rhyme or a poem than a song. But anyway, so y prime is going to equal, here's my low, here's my high, and my derivative of high equals 1, and my derivative of low equals 2x, just to help me out. So I have low d high, which is 1, minus high times d low over, I can zoom in, sorry, I'm bad at zooming, especially when you're not here to tell me, over the square of what's below. So I have x squared plus 3 squared. Cool, now let's distribute everything out. So I have y prime equals x squared plus 3 minus 2x squared plus 2x over x squared plus 3 squared. And then simplify, so y prime equals negative x squared plus 2x plus 3 over x squared plus 3 squared. So remember, I want to find where the derivative equals 0, so I'm going to set this thing equal to 0 now. So, and I'm also, while I'm setting it equal to 0, I see I have a negative in front of my x squared. So I'm going to make that positive, and then these two things negative, because I think that will help me in the future. So I'll rewrite it as positive x squared minus 2x minus 3 over x squared plus 3 squared equals 0. So if I multiply both sides by x squared plus 3 squared to cancel it out over here, I'll still get 0 over there. So I have x squared minus 2x minus 3 equals 0. And I can factor x minus 3 times x plus 1 equals 0. And I get x equals positive 3 and x equals negative 1. Now I'm not going to leave my answers like this, because the question is asking for the points at which the graph of the following function has a horizontal tangent. So I need to find the points, and I'm going to do that by plugging x back into my equation for y. So I need to plug these into y. And I get 3. When I put 3 in here, I get 2 in the numerator, and I get 12 in the denominator. So 2 over 12 is the same as 1 over 6. And this one I get negative 1. And when I plug in negative 1, I get negative 2 over 4. And that's the same as negative 1/2. So now I'm done. I have my points. Voila. Cool. So now I've learned how to find the equation of the tangent line to a graph at a point, and find where the graph has a horizontal tangent. There's just a couple more problems. These ones I think you might think are fun. They're kind of like a little puzzle. So what I do for these is I need to apply the power rule here, or the product rule here, or the quotient rule here to these equations. And then after I do that, I plug in the specific values that I get for g of x or g prime of x or whatever. So I'll show you, and I think you might think it's kind of cool. Let me figure out which one I want to do. Let's do C, because I feel like the other ones might be a little easier. I'll do C. Ooh, there's really not much space, so I'll try to write really small and zoom in really far. Okay. So again, I'm just going to find the derivative. So f prime of x, I'm going to use low d high minus high d low over the square of what's below. So I have low d high, so times the derivative of g of x, minus high d low. The lights just turned off, because it's just me in here. Okay, there they go. Minus low d high, or minus high d low, and derivative of low is going to be 2 times h prime of x, all over the square of what's below, so 2hx squared. So I found the derivative, and now I'm just going to plug in the values that I'm given. So I'm given all the values that I need here. So 2h of x is equal to 3, g prime of x is equal to negative 2, minus g is equal to 4, times 2, h prime is equal to pi, over 2, h is equal to 3, and then this is all squared. So I plugged everything in from that table, and now I just simplify. So 2 times 3 times negative 2 is negative 12 minus 8 pi over 6 squared is 36. Okay, I could divide everything by 4 to simplify it a little bit, so it's negative 3 minus 2 pi over 9. Yay! Okay, and then the last thing is we're going to talk a bit about the second derivative. The second derivative? What's that? So we've been learning the first derivative, and then the second derivative is when you just take the derivative of the derivative. So I'll read this beautiful thing. The second derivative of a function y equals f of x can be written as d2y over dx squared, or f double prime of x. The third derivative is d cubed y over dx cubed, or f triple prime of x. Okay? So the second derivative of a function is the derivative of the function. So for each of the following, find f double prime. We'll find f double prime of this one. Okay? F double prime. Okay. So f double prime. First I'm going to rewrite this, sort of like what we were doing in class, because I could take the quotient rule. I mean, I could take the quotient rule, but should I just take that? No, I'm going to do it how we did in class. I think I'm going to prefer that way. So x squared over x plus 4x over x minus 2 over x equals x plus 4 minus 2x to the negative 1. Okay, so I just rewrote f of x. And now, to find the derivative of this thing, I'm just going to use the power rule on each of these things. So f prime of x equals the derivative of x is just 1. The derivative of 4 is 0. And the derivative of negative 2x to the negative 1 is plus 2, because I multiply negative 2 times negative 1 times x to the negative 2, because I subtract 1 from that. Cool. And then f double prime of x, so this basically goes away. F double prime of x is now I just take the derivative again. So the derivative of 1 is 0, and the derivative of this is minus 4, because I multiply 2 times negative 2, x to the negative third. And I can rewrite this like this. Negative 4 over the, over x to the third power. Sorry. Okay. Maybe I will also do this one, which involves the quotient rule, just for another example. So f prime of x equals low d high, so low, the derivative of the upper, which is 1, minus high d low, the derivative of low is just 1, over the square of what's below. Okay, so I'm going to simplify that. This is equal to x plus 1 minus x over x plus 1 squared. So these cancel out, it's just 1 over x plus 1 squared. So to find the second derivative, I'm going to use the quotient rule again. So I just have 1 over x plus 1 squared. I'll do the quotient rule. So I have low d high, x plus 1 squared times the derivative of high. The derivative of 1 is just 0, so that's kind of nice. That'll cancel out. Minus high d low. Oh, we haven't learned how to do d. So the derivative of this thing, shoot, we haven't learned how to do that yet. That's called the chain rule. I'm going to cut this part out. Okay, bye.